Today we're going to talk about inverse trig functions. Inverse means an opposite or a backwards operation. Everything we do in math to a number, we should have a way to undo. So we can undo adding by subtracting. We can undo multiplying by dividing. We can undo squaring by taking square roots. Okay. So if we're doing a sign of something or some other trig value of something, we should have a way to undo a sign or a trig value. And that's called inverse trig. I think of this lesson kind of like Jeopardy. So in the previous lesson, I gave you a trig function like sine. Okay, that's like our category. And I gave you an angle, like 30 degrees. And it was your job to come up with the answer to that, the fraction. Okay? This lesson, I'm still going to give you the category. And I'm going to give you actually the answer, and your job is to come up with what the question was. Like on Jeopardy, they say, what was whatever. Okay, so we're coming up with like, what was 30 degrees? Okay, we're trying to find the angle in these problems. So in the last lesson, we had the trig and the angle, and we wanted to come up with the SOHCAHTOA fraction. In this lesson, you're going to have the trig function and the fraction. You want to come up with what angle gave us that fraction. For this lesson, our circle and our two special triangles are going to be really important to us. Right? So this just says this is our way of undoing a trig function. We call them inverse trig. They're also called arc functions. So we say things like arc sine and arc cosine and arc tangent. Our notation is that little -1 notation. We talked about that. I don't like. It doesn't mean a negative power. It means an inverse. So when we see something like this, what this is asking us is what angle had a sine of a half. We're trying to work our way back to that angle. Okay? So when you see this notation, it's asking us for an angle. So to do these problems, again, our circle is going to be really important to us. So on that circle, we labeled our points around the axis line. Over 1 up 0. Over 0 up 1, back 1, and down 1. And then our angles. Our two triangles are going to be really important to us also. So our 45, 45, 90. And our 30, 60, 90. Okay. These things are going to be crucial to have memorized for the quiz next week. Being able to draw them out like I just did is going to be really important. I would suggest that when you get your quiz, you just draw them out right away on top of it, and then you'll have it to refer to for problem solve throughout the quiz. But this is going to be really important to us. All right, so for the first one, it says inverse sine or arc sine, that's what that little -1 means, of square root of 3 over 2. So this is asking what angle has a sine of square root of 3 over 2. So to do this, we need to think about SOHCAHTOA. What is SOHCAHTOA for sine? Opposite over hypotenuse. Okay, SOHCAHTOA for sine is opposite over hypotenuse. So this tells us that our angle needs to have a hypotenuse of 2 and should be opposite of a square root of 3. So what angle has a hypotenuse of 2 and is opposite or across from a square root of 3? What angle is across from the
30.
square root of 3?
Oh, across 60.
60. Okay, so our answer is 60. There's a hypotenuse of 2, and it is opposite of our square root of 3. The directions say to evaluate both degrees and radians. So once we have our degrees answer, we want to turn this into radians. What was our conversion for radians?
180 over 5.
180 and pi are the same. So what we want to think about is how many of these does it take up to make a 180? So how many times does 60 go into 180?
3.
3. So 180 divided by 3 is equal to 60. So it's pi over 3. do our conversion, we think about how many times does that go into 180? And pi is 180, so we do pi divided by however many times we need to divide it in. Cosine of -1. Alright, so first, I could think about this as being over 1. Okay, we can make anything into a fraction over 1. And then SOHCAHTOA for cosine is adjacent over hypotenuse. So I would be looking for an angle that is adjacent or next to a 1 and has a hypotenuse of 1. But there aren't any triangles with a hypotenuse of 1. So the triangles don't work here because there's no hypotenuse of 1. So that means we need to look to our circle. In our circle, all of those points are cosine comma sine. So if this question is asking about cosine, that means the first value in our point should be -1. We don't know what the second value is, but it doesn't really matter. We just want to make sure that the cosine, the first part is -1. So where in the circle is the first part of the point -1?
180.
At 180.
So it's 2 for 5.
And how many times does 180 go into 180? Once. So 180 is pi. For tangent, I'm going to go ahead and make this into a fraction again. What's SOHCAHTOA for tangent?
Opposite over adjacent.
Opposite over adjacent. So I need to find an angle that is across from a 1 and next to a 1. So what angle is both across from a 1 and next to a 1? The 45. And how many times does 45 go into 180?
4.
4 times. 180 divided by 4 is 45. So pi divided by 4 is 45. Questions? For the first one here, we need to unsimplify this. Okay? So you'll have this in your assignment as well. The book likes to rationalize things, which is actually the right way to present numbers. We're not supposed to leave square roots on the denominator. When you see a fraction that has the same number under a square root and not under a square root like this, it came from rationalizing the denominator. This is the same thing as 1 over square root of 2. Okay? Anytime you see the same number under a square root and not under a square root, it's 1 over that square root. Okay? So you won't see these numbers because they're not special triangles, but even if you had like square root of 7 over 7, that's 1 over square root of 7. Okay? Then you'll be able to evaluate it for the triangles. But we don't have a triangle that has a square root of 2 and a 2 in it. So we can't evaluate that without unsimplifying it. Okay, so you'll need to do that in your assignment as well. Whenever it's the same number under a square root and not under a square root, it's 1 over that square root. Okay? Alright, so go ahead and try these 3. Okay, so for sine, after we unrationalize it, we want to think about SOHCAHTOA. What's SOHCAHTOA for sine? Opposite over hypotenuse. So then I need to find an angle that has a hypotenuse of a square root of 2 and is across from a 1. So what angle would that be? 45. And 45 goes into 180 4 times. In those two triangles, you are not allowed to select the 90. Okay, SOHCAHTOA only works when we're working with one of the acute angles in the right triangle. Doesn't work for the 90 because 90's opposite is the hypotenuse. So you can never choose the 90 from those triangles. That's why I didn't even label the 90 because it's not a choice from those. If 90 is going to be an answer, it's going to come off of the circle. So if you know you're working with a square root of 2, the only place the square root of 2 is in the 45, 45, 90. And the only answer there is 45 because it can't be 90. So that really limits down your options. These questions are kind of like a multiple choice question with a word bank of like 7 options, right? Because you can answer any of the angles around the circle, so 0, 90, 180, or 270. You can answer 45, 30, or 60. You've got 7 possible answers on these. Okay, so these questions are kind of like a multiple choice question or a matching question. For 0, there's no zeros in the triangle, so I don't even need to bother thinking about SOHCAHTOA here. If we have a 0, we have to be coming off of the circle because there's no way to get a 0 in a triangle. So in the circle, all the points are cosine comma sine. So if this is a sine value, it goes in the second part of the point. So I need the place that has a 0 in the second part of the point. There's actually 2 possible answers here. Really, actually 3, I guess. We could say that it's 0 degrees, which is 0 radians. We could say that it's 180 degrees, which is the same thing as pi. Or we could say that we went all the way around our circle and got 360 degrees, which is 2 pi. Any of those sets of answers is okay. You don't need all 3 of them. Any of them would be acceptable, though. I would accept any of those answers on the quiz for a question like this. Okay? Those are all places where the second part of the point is 0. Technically, the best answer is the 0 answer. That's what we consider to be the principal answer because it's the first answer that we come to. So technically, that's the best answer. That's the one your calculator would give you if we would do these on our calculator. But I will accept any of them.
How do you say pi with 270 at the circle?
3 pi over 2 is the same as 270. It's 1.5 180s, but we write it improper. And the last one here was already unrationalized, but in the book you might see this as square root of 3 over 3. Okay, and then you'll have to turn it back to 1 over the square root of 3. SOHCAHTOA for tangent is what?
Opposite over adjacent.
Opposite over adjacent. So I need an angle that is opposite of a 1 and next to a square root of 3. So what angle is across from a 1 and next to a square root of 3?
30.
The 30. So in that triangle, I've got my 30 is across from the 1 and right next to the square root of 3. And 30 goes into 180 6 times. Questions? The quiz that we will have on Tuesday that covers lessons 1 through 4 will be a non-calculator quiz. Okay? I will allow you to bring a calculator that does not have the buttons sine, cosine, and tangent on it, no cell phone calculators. But if you can find in your house like a little tiny calculator that doesn't have sine, cosine, and tangent buttons, you can bring those. Or I guess some of them are actually huge. But if it doesn't have the sine, cosine, and tangent buttons, you can just add, subtract, multiply, and divide. You can bring that if you want, if that makes you more comfortable with arithmetic. But when we take our quiz, I'm not going to allow you to use a calculator that has those buttons on it because this quiz is going to be on doing trig by hand. So it's going to be on this type of problem and then the type of the problem from the last lesson where we did our trig by hand with these special angles. The next couple types of problems we're going to look at today, we will be using our calculator for, which means that they're not going to be covered on this upcoming quiz. Okay? But just a heads up that you might want to start looking around your house this weekend for a calculator that does not do sine, cosine, and tangent. Okay, the purpose of inverse trig is to be able to solve for missing angles. Okay? Regular trig tells us about the sides of a triangle when we know angles. Inverse trig tells us about the angles when we know about the sides. So in this one, if I want to find out how big that angle is, then I need to think about what sides of the triangles I know. Is mine in the same place as yours? The top corner?
Yep.
Yeah, okay. It looks like it kind of got shifted off or something, but so according to that angle then, what kind of a side is 5? Be more
adjacent.
An adjacent.
Sorry.
It is a leg, but more specifically, it's the adjacent leg. And then what kind of a side is 9?
Oh, hypotenuse.
The hypotenuse. So we're working with adjacent and hypotenuse, which means we are doing which trig function? Cosine. So cosine of our angle should be equal to 5/9. To solve for the angle, we need to do the inverse trig. So we're going to do the inverse cosine of that fraction to get our angle. We can do this on a calculator. Like I said, this type of question will not be on your upcoming quiz, but it will be on your assignment tonight. On your calculator, to do an inverse, we press the second button. So you're going to press second cosine 5/9 to find an angle of about 56 degrees. Okay. Your iPhones will do this as well. If you turn them on their side, they have their trig button, and there is a shift or a second button that will turn it into the inverse cosine. You have to type it in backwards, so you have to do the 5 divided by 9, enter, and then do your inverse cosine. But it will work on those as well. Questions? Okay, so label the sides according to the relationship to the angle you want to find. Pick which trig function you're going to do, and then do the inverse trig function of that fraction. And this one, my theta is definitely floating somewhere it shouldn't be. Where should it be? The bottom corner?
Yeah.
Okay. All right, so go ahead and try this one. Okay, so according to theta, 7 is our opposite, and 12 is our hypotenuse. So the trig function that uses opposite and hypotenuse is sine. So we're going to take the sine of our angle to be 7/12, which means on the calculator we want to do our inverse sine or second sine of 7/12. And that gives me about 35, which I didn't write, 0.7. Right. The directions in this problem, and actually the last one too, and I didn't read carefully enough, say to solve it in both degrees and radians. So this is our degrees answer. We could convert this by hand the way we learned the other day into radians, or we could let our calculator do it for us. If you press your mode button on like the third or fourth line down, you're going to have two options of radian and degree. Select radian, and then go back out and calculate it again. You can actually just hit enter. You don't even need to type it in again. Just hit enter, and it'll actually recalculate it in radians to give you about 0.662, or I guess we could round up that last 2 and make it a 3.
How do you type calculator went off on key?
To type it in, you do second sine 7/12. Your calculator will open up some parentheses when you hit the sign button. It doesn't actually matter if you close them off or not in this problem. Okay. So some of your homework problems just say find the angle. If it just says find the angle, find it in degrees. Some of your problems will say find it in both degrees and radians. So then when you need to do that, you can just switch your mode back and forth. iPhones have an option to switch mode as well. So you can do that there on those also. Okay. Pay attention to what mode your calculator is in though, so that when you're supposed to give degree answers, you give degree answers. All right, our last type of problem says solve the equation. Sine of theta is -1/4. Okay, so that means we want to find theta. We want to find our angle. So what we're going to start by doing is doing the inverse sine of -1/4. So I'm going to do that on the calculator. Now it says between 180 and 270. That means we need to work in degrees. So we need to make sure we are in degree mode on our calculator. And I'm going to do the inverse sine of -1/4. And the calculator tells me that is -14.5. That's a little bit of a problem because it tells me my answer is supposed to be between 180 and 270. And for -14.5 is definitely not in that range. Our calculator gave us an answer of this, negative 14.5 degrees, if we graph it out. We want our answer to be somewhere in this range. What we can do is reflect this angle over any quadrant we want to, keeping our reference angle the same. So if I want it over in that third quadrant, I can just flip it over into there and keep that reference angle the same. Okay, so it gave us an answer in the fourth quadrant. We want it in the third quadrant. Just flip it over into there, keep your reference angle the same. Our final answer is then taking the actual angle measurement from our starting line around to that angle, which would be what? 194.5. Half the circle is 180 plus that extra little bit, so 194.5. Okay, so we start by letting the calculator give us an answer. If that answer is not in the space they told us to have our answer, we flip it into the right quadrant and then measure around from the starting line. So for this one, we're going to start by doing an inverse cosine of negative 2/3. So on the calculator, second cosine of negative 2 divided by 3 gives me an answer of 131.8.
So close.
That is not between 180 and 270, so that's not going to work as our final answer. So I want to graph this answer. 131.8 is somewhere in here. We need to find our reference angle. How do I find my reference angle? 180 minus the 131.8 will give me how much is left over down here, 48.2. Our answer is supposed to be down in that third quadrant. So I'm just going to flip my answer down into that third quadrant, keeping the reference angle the same. Then recalculate from our starting line around to that angle, which would be 180 of the top half of the circle plus that reference angle of 48.2, and we get 228.2. You can check your answer on the calculator on these because we know that this equation should be true. So I know that the cosine of whatever I think my answer is should be equal to negative 2/3. So I can do the cosine of 228.2, and my calculator tells me it's negative 0.6665. That's pretty close to negative 2/3. We did some rounding, so it's not perfect, but you can check your answer that way. Your homework is from section 4.